In this section, we're looking at simple interest. So we have a situation where we're investing some sort of money, typically into an account. Maybe that's a savings account or some sort of CD, certificate of deposit. It could also be a different type of investment, a bond, something that is related to stocks. But we're going to assume that we're getting a regular percent of return. And in this case, it's not compounded. So we'll see what compound interest is later. But we're getting the same, basically the same amount of money each year based off of that percent. So we've got two main formulas, which is the interest, I, is just P, the principal, times R, the rate. We're going to write that as a decimal, times T, the time in years. So if we're given something in months or days, then we've got to alter that and just make sure that we are in years. And we're going to have Excel do the work for us, right? This is a pretty straightforward equation. It's just multiplication, but we're going to still have Excel do that for us. The total amount accumulated, well, the interest is just what you gain on top of the money that you originally put in, the principal, P. So at the end of the day, right, in your account, you have P, the principal, plus whatever interest you gain. So that's A equals P plus I. And then we just substituted for I, the formula above. So this is giving you a couple different versions. But again, we're going to have Excel do the work for us. So let's take a look at this example. We're going to suppose we deposited $5,000 at 4% simple annual interest. Again, in the future, we'll see compounds. So this is, we call it out just by seeing that word simple. So pretty straightforward in that regard. All right, and we're not making any other payments, so this is a one-time deposit, and we're just going to let it sit in there. So how much interest is earned after 1 year? Well, we know that our P, principal, is 5,000. We know that our rate, R, it's 4%, but we're going to write it as a decimal, 0.04, right? Not 0.4, that would be 40%, 0.04. Move the decimal 2 places to the left. In part A, the 1 year tells us that T equals 1. So we could certainly say, all right, if I equals PRT, then we can just toss these values in, 5,000 times 0.04 times 1, which is not super exciting, and figure out what this is. But let's see what Excel has to say about it. And of course, we could just use our calculators for this one, or we could even in a single cell within Excel have this formula. But for us, I tried to set this up to be pretty straightforward. So we're going to fill in the yellow area. So our principal P is 5,000. Our interest rate, notice I said percent or decimal. So here's what I mean. You can either do 0.04 or you can tell it 4%. You have to put the percent symbol though, otherwise it's going to think you mean 4 as a decimal, which is really 400%. And then our time in years, in this case, it's just 1. And then down here, we're going to see that our total interest earned is 200 and our total value is 5,200. So really, this gives us both of the things we could be interested in finding out. So for this particular question, we were wondering how much interest was earned. And our formula would tell us this, but also our template is telling us that this is 200. How much is in the account at the end of 1 year? Well, again, we can either say I started with 5,000, I added the 200, so now I have 5,200. So that's one perfectly fine way to go about this, right? The principal plus the interest. Or we could say, well, this was just another one of the outputs. Once I put in the initial information, this was the second thing, the total value at the end, at maturity. In part C, we say, well, how much interest is earned after 5 years? So let's say we kept it in there for a while. Now, of course, the only thing this is really changing is that T equals 5 instead of 1. And this, again, is the nice thing about our template here is we say, well, if I want to keep the principal and the rate the same, all I got to do is change the time. Okay, just going to hit 5 and then enter. And now we see we earned $1,000 in interest and our total value is 6,000. And these guys actually, let me tack on the thousands here so that if we do have something with dollars and cents, then we could adjust accordingly. Okay, so here, let's go back to what we were seeing. So how much interest is earned after the 5 years? That was the first figure we saw. So that was the 1,000. How much is in the account at the end of 5 years? Well, that was, right, again, the initial 5,000 plus this interest. So the second value that the template gave us was 6,000. And so we can carry on in this fashion. These questions don't really get much harder in this regard. We just say things like, how much is in the account at the end of 6.5 years? So we can do things like this where we kind of have, slightly more interesting timeline. So t equals 6.5. Okay, well, that's not too crazy. So we're going to go back over to our template and say, okay, I'm going to change t to 6.5, hit enter, and right, this one asked for how much is in the account, the second value. So 6,300. Again, you could do this by hand, but as long as we have the template there and we're using the same values over and over again, right? The same $5,000 initially and the same 4%, we might as well use it. And then part F says, well, how much is in the account at the end of 7 months? So this is the only one that's probably actually tricky, right? So far, we've been able to say t equals this, t equals this. If t has to be in years, then we don't want to say 7, right? 7, if I put that in, means 7 years. But what I could do is say, well, what fraction of a year is this? Right? Well, it's 7 out of 12. There's 12 months in the year. So t is 7/12. Here's something we want to be careful about. When we go to put this into our simple interest formula here, right, into the template, if I just say, okay, well, this is 7 divided by 12, right, it's going to give us a weird value, and we've seen this before. It's going to interpret this as a date. So instead of doing that, let's say, okay, well, for sure, I don't want it to interpret that way. So one thing I could try is I could say, well, what about equals 7 divided by 12? Right? Again, it's going to give us this sort of weird value here. So just kind of double check, that what we're looking at here. Instead of custom, let's make sure it's as a number or as a fraction, right? Either way, that's fine. So if we do that, then we see more realistic values here. So fraction, and again, sometimes, the fraction looks a little bit bizarre in this format. What we see up in the formula bar is the real value. This one, right, it wasn't 3/5. That's not 7/12 simplified. So occasionally you're going to see little inconsistencies like that. One thing you could do is say, well, by default, fractions have 1 digit in the denominator. You could go to 2 digits. And now we're back to the value we see. Or again, you could just change this back to number, and if you want to, extend the decimal places, that's totally fine. Whatever works there. But we end up seeing a much more reasonable value, right? Especially based off the other numbers we were seeing. We clearly don't have $8 million or whatever that first thing was. So let's see, what did we want? How much is in the account? So we want that second value. So we have 5,116 and 67 cents. And the way that this is set up, it'll round to the nearest cent for you, so you don't have to worry about that, which is one of the nice features. Okay, let's look at another example here where we're applying this. So one time where you see simple interest quite a bit are Treasury Notes. This is a type of bond. And so basically what happens is you give your money, you give your 5,000 to an entity. In this case, it's going to be the US government. And they're going to pay you back simple interest every year for a long time. In this case, it's for 20 years. And at the end of all that, you're going to get your $5,000 back. So very similar to the scenarios we were talking about. There is a penalty for early withdrawal usually. But anyway, this is sort of the idea. So we know that we're putting in initially 5,000. So that's like our principal, P. We have 1.939%. So we know that our annual rate is 0.01939, right? We moved the decimal twice. And then as far as the time goes, well, it's a 20-year Treasury note. So this is going to be T equals 20. So we want to know how much interest we would have earned. Again, we're getting our 5,000 back. So we're just kind of curious, like, all right, well, during those 20 years, how much interest would I get? So let's go back over to our template. We're putting in 5,000 again, right? That number's actually the same just by coincidence. Our rate R is, again, you could do 0.01939, or you could, and if you want to see more decimal places, that's totally fine. You can do that. And then our time in years, this one was pretty straightforward, right? We said it was just 20. And so we get our interest earned is 1,939. That number looks fairly similar because it was what our interest rate kind of looked like. So that was just a product of the fact that 20 times the 5,000, that part of the PRT equation just ended up basically being a multiple of 10. Move the decimal over. So 1939 is our answer. So that's how much interest we earned. So these ones are pretty straightforward. I wanted this first section to be, kind of a nice lead-in. Things obviously get a little bit more involved from here when we're talking about finances. So we're going to be doing deep dives from here, but this is at least a nice little intro